In this video, I'm going to do a quick overview of the laws of exponents we've already explored. I'm going to show you a new one, and then we're going to simplify 5 expressions using these laws. We've explored most of them already in the shorter videos, but I want to go more in depth and I want to talk about different angles and ways to look at these problems as opposed to just the straightforward tips and tricks. As you can see here, we've already talked about the multiplication rule, where if the bases are the same, okay, the base in this case is a variable, it could be a number too, you can add the exponents. So we say exponent x and y, we have a to the x plus y. And if those are numbers, you can just add them. Division rule, same concept. If the bases are the same, we can subtract, okay? We subtract the second exponent from the first. We have power of a power rule. So if you raise, okay, a power to a power, you are multiplying those. Okay, so this power a to the x, this exponent here is being multiplied by the y, and you get a to the xy power. Again, those are numbers, okay, in the cases we're going to be working with. Those x and y's are going to be actually numbers. Those are just kind of placeholders for the time being. Power of a product rule. So if you have a couple things inside of a parentheses, each one of those things gets raised to the x power. So you can see here, the a gets raised to the x power, and the b gets raised to the x power. Power of a fraction rule. So we didn't really see anything like this yet. We may run into it, we may not. I'll leave that as a surprise. We have a over b, okay, in this case, and they're both being raised to the x power. The negative exponent rule is something we've also seen. I talked about it. Basically, if you have a to the negative x power, you can imagine every single quantity is over 1. So I'm just putting that there over 1 so you can see that, okay? And if you put it over 1, it basically will flip to the bottom and that negative exponent becomes positive. If it starts negative on the bottom, okay, I don't want to go too far into this, but let's just look at it. If I have 1 over a to the negative x, I can bring the a to the x to the top. That negative x becomes positive. It becomes a to the x over 1 or just a to the x. One of the rules we have not talked about yet, okay, the zero exponent rule. If you raise any quantity to the 0th power, it's going to equal 1. We're going to run into that. Just realize that even if it's a single variable, like in this case, a to the 0th power, it's going to be 1. But if I have like a quantity, say I have like a times b to the 0th power, it will also be 1. Anything in the parentheses would come out to be 1. This fractional exponent rule, we're going to hold off on this for now. Okay, this is kind of a different section. This is something we probably come into contact more in Algebra 2 or college algebra, something of that nature. All right, let's get into these problems. Okay, the first expression I have here is the quantity 2v to the 2nd power times 2 times v to the 2nd power. When I say the quantity, I'm referring to something inside of a parentheses, okay? It's just a verbal description of what's happening. If I didn't say the quantity, if I just said 2v to the 2nd power, you might think that only the v is being raised to the 2nd power, but they both are being raised to the 2nd power. Okay, that's the power of products rule. Okay, I recommend to have that laws of exponents reference sheet or something like it at your side when you're first starting out with this until you really get comfortable with the rules. It makes it easier to reference those rules quickly, you know, or just to see examples that might help you out while you're simplifying an expression. So let's do this right off the bat. Okay, if we have this exponent here, it's going to raise both of these values to the 2nd power. This is important here. Okay, and going a little bit more in depth, you can imagine that the 2 and the v both have an exponent of 1. If a number or a variable doesn't have an exponent, it does. It has an exponent of 1, okay? So what I actually did here was I multiplied each of those imaginary ones by 2. And that's why I got 2 to the 2nd power and v to the 2nd power. And then I can write the rest of my problem. Okay? Now I can simplify if I can simplify. We can do a decent amount of simplification with the variables, but let's take care of this number first. So if you see a number or something where like an order of operations type of thing, where you can simplify a constant or a number, do so. 2 to the 2nd power is 2 times 2. That leaves us with 4v to the 2nd power times 2v to the 2nd power. Now, we didn't run into a direct example of this in the shorts. when we had coefficients in front of these. Keep in mind, guys, this is just one long multiplication problem. Even though there aren't dots between the 4 and the v to the second power, there are. They're being multiplied. You just don't have to write these multiplication dots when you have a number next to a variable. Okay? But these are basically 4 things being multiplied together. And we can multiply them in any order. So I could switch the position of the v to the second power and the 2 to make it easier for myself. I wouldn't do this every time once you get better at it, but to start off, it could help you out. Okay? So all I did was switch the position of these two. Now I can do 4 times 2, which is 8. You are not adding those. Don't fall into that trap. These are not exponents. These are just numbers, okay? You're multiplying those. But here, in this case, I have 2 variables that are the same. I am multiplying those together. I can add those exponents. So I end up with v to the 4th power. My final answer here. So this expression involves division. There are a few ways I could approach this. I could multiply these x to the thirds together first, or I could divide x to the third divided by x to the second power. It doesn't matter in this case, but sometimes it does. But you have to understand knowing different angles and how to approach things can help you in the future, because sometimes one technique makes the problem solvable or simplified to a better extent. So let's multiply the x to the third times x to the third first. Remember, we can multiply these in any order. I could basically interchange those 2 variables. So x to the third times x to the third is x to the 6th power. And then I have y to the third right next to it. Now, I want to consolidate my x's. I can keep going here because these are both x. I can subtract the larger exponent, right? Or the smaller exponent from the larger exponent. So I have 6 minus 2, which gives me x to the 4th power, and y to the third right next to it. Now keep in mind here, the reason why the x to the 4th stayed next to the y to the third is because the exponent is larger, okay? You can kind of imagine that this whole thing is over 1, and we canceled out this x to the second power and left the 1 on the bottom. But we don't keep that 1, okay? We don't need it. The divided by 1, when you divide anything by 1, it's actually just itself. So this is our simplified answer. Okay, so we have a quotient again. And we have a product inside of parentheses. And thirdly, we have a negative exponent. So let's talk through this. A good strategy, going back to that first example I showed you, put a little 1 here. Give an exponent of 1 to the 2. It's just going to make things easier. It's going to remind you to multiply each of these exponents by negative 1. So if I do that, I get 2 to the negative 1st power, m to the negative 2nd power, all over m to the 2nd power. Okay, again, 1 times negative 1 is negative 1. 2 times negative 1 is negative 2. Now, one key aspect, okay, that might not be told, it's kind of an unspoken rule, unless it says otherwise in a textbook, which it does sometimes. You never want to have negative exponents in a final answer. Never. There are certain cases, though, in a textbook where they're with preliminary problems where they're trying to warm you up and they don't want you to get too into it, and they might just say keep your exponents negative. In this case, we're not going to do that because we want to simplify it the whole way. So remember the practice. If you have a negative exponent and it's in the numerator, you can make that exponent positive by taking the entire part and bringing it to the bottom. Okay, and that goes for this 2 base and for that m base. Okay, so let's do that. I'm going to bring everything down to the bottom. I have 2 to the 1st. Notice the negative exponent becomes a positive 1. I have m to the 2nd. Okay, and that's from this here, that negative 2 turning into a positive 2. But I also have another m to the 2nd power. What happens up top? If everything goes from up top, we can't just put a 0 there because 0 divided by this quantity is going to make it 0. We leave a 1 up there because essentially it's a reciprocal. Okay, we are creating the reciprocal 1 over 2 and 1 over m to the 2nd power. And 1 times 1 would just give you a 1 up top. We're almost there. We're almost finished. The last step would be to combine these 2 variables and by adding their exponents. So now I have 1 over 2. I no longer need that 1. okay? You don't want to keep an exponent of 1 in a final answer. It's not really good practice. M to the 4th power. The final answer is 1 over 2 times m to the 4th power. All right, this one we got a few things going on here. Okay, we do have a product inside, and we're raising those products to a power, all right? And then we've got another quantity over here. Like I said, just starting out, if you see a variable with no exponent, give it an exponent of 1, okay? You can even give your numbers an exponent of 1, okay? Honestly, it's not going to help in this situation, but just to be absolute, it's a good idea just to start out. So what we need to do is we need to take care of this quantity first. Now, remember, when we raise powers to powers, we multiply. So every single one of these quantities, 2, x, y, they're all going to get the negative 3rd power. So the first thing I have is 2 to the negative 3rd power. That's 1 times negative 3. Now let's stop right here. I could multiply, all right? I could multiply these and get x to the 0 power again, because 0 times negative 3 is 0. You know, you can just turn this into 1 immediately. Remember, this was that new rule I introduced. X to the 0 power is just 1. So basically, it's like I'm multiplying this by 1 times y to the 2nd power, okay? It's gone. I don't even need it anymore. If you raise 1 to any power at all, even if I raise 1 to the negative 3 power, okay, it's just 1. Anything. 1 to any power is always 1. So, I mean, let's just put it in just for good practice. Let's change that to a 1. What's the exponent? Also a 1, right? Because I'm just deleting this and I'm making it a 1, and I'm giving it an exponent of 1. So now I have 1 to the negative 3rd power. Okay, you have to understand that this is just going to equal 1, but just to go through the procedure, let's do it. 2 times negative 3 is negative 6. And then I have the rest of my quantities over here. 2 times 1, okay, y to the 1st, x to the 3rd. This is one giant multiplication problem, okay? And again, if these marks are too much, you can kind of exclude them, but I'm trying to make you guys understand that dots in between, or when there's a long line of values, you can put dots in between because it's just one giant chain of multiplication. There are 6 things being multiplied together here. And we're basically just trying to move them around in our head or on paper to match them up. Like, look at my 2's here. They both are the same base. I can add their exponents, even though the bases are numbers. I have 2 to the negative 3rd and 2 to the 1st. Well, what's negative 3 plus 1? I recommend if you're not comfortable with negative numbers at this point, like if you didn't learn them well when you were younger and you're still trying to get back into it, use a calculator for now. That's okay, because you need the calculator to support you for these higher skills, and you'll start to learn your adding and subtracting of negative and positive numbers as you go. So I have 2 to the negative 2nd power. That's from adding negative 3 to 1, okay? Now, this 1 to the negative 3 power, guys, I'm going to exclude this. It's just times 1. This ends up just being 1. Anytime you multiply something by 1, it just becomes itself. It's irrelevant, okay? So I've taken care of the 2's. I took care of this 1. Now I have y to the negative 6th and y to the 1st. Negative 6 plus 1 is y to the negative 5th. This x doesn't have anything to combine with. I'm just going to put x to the 3rd power. We're almost there. We have to move a few things around. We don't want negative exponents in our final answer. So what do we have to do? Well, we can imagine this is all over 1, and we can move these to the bottom. So let's do that. The x to the 3rd stays on the top. The exponent is positive here. It is not moving. But these 2 can come to the bottom. So now I have 2 to the 2nd power, y to the 5th. We're there. There's one more bit of tidying we can do. X to the 3rd. Can we simplify 2 to the 2nd power? We can. 2 to the 2nd power is 2 times 2, which is 4. And then we tag on our y to the 5th. This is our final expression right here. All right, last one. We got a lot going on here. We got quotients. We got products in parentheses. Let's do it. Let's take care of the products inside the parentheses first, being raised to a power. This is something I always recommend you do first, depending upon the complexity of the expression. So like in this case, it's important to do. It is the most complex part of this thing. It has to be taken care of immediately, okay? Think of it as a package. You can't really open that package until you apply this exponent. So let's do it. Let's give all our numbers or variables an exponent of 1 if they don't have an exponent, all right? Remember, we're going to be multiplying these exponents by 3. So 1 times 3 is 3, so I have 2 to the 3rd power. 3 times 3 is 9, I have x to the 9th power. This is still just the numerator. 2 times 3 is 6, I have z to the 6th power. I put a line through my z's. I give them a little mustache. Otherwise, to me, sometimes they look like 2's. That's what I do. So I have x to the 3rd on the bottom, y to the 4th, z to the 2nd. I'm not going to put that dot there. It's not necessary. Everything is being multiplied. They're not trying to trick you. They're just trying to make you realize that, or they're trying to imply that these two things are separate quantities. But in the end, we can just multiply straight across. Okay? There are a number of ways to approach this. All right? A number of ways. I'm going to scroll down a little bit. So, what we could do, first thing I would do is simplify this. Okay? But in the process, we can also subtract exponents as we go. Now keep in mind, this is how you do it. Wherever the exponent is the highest, that's where it should remain, the variable, okay? So I'm going to do 2 to the 3rd power, which is 2 times 2 times 2. That's 8. Okay, I'm taking care of that first. I'm going to put my long line across. Now my x's, okay? Well, there are x's on the bottom, okay, that can be combined. There's also z's. Let's take care of those first. I could do x to the 9th divided by x to the 3rd. I could. For me, it's easier to take care of things all on the top in the numerator and all on the bottom, the denominator, separately, and then start subtracting. Okay, that's something I prefer to do. Honestly, though, if you did it this way, as long as you kept the x up top, right, 9 minus 3 is 6. If you said x to the 6th, then got rid of that x to the 3rd power, you could continue simplifying, because remember, we have another one here. But let's just do them left to right first. I'm going to rewrite everything on top as is. I have x to the 3rd power and x to the negative 4th power. Well, I have 3 plus negative 4. Remember, if we multiply, we add exponents. So I have x to the negative 1. That's 3 plus negative 4. Look at my y's. Are there any other y's below? Nope. I'm just going to keep it as is. And what about my z's? I have z to the 2nd and z to the 3rd. Well, that ends up being z to the 5th. Now I can start subtracting, okay? So I'm going to go left to right here, since I've run out of space on the bottom. I can subtract, and what I mean by that is the 8 and the y to the 4th, I'm going to write those first. Why? Because those aren't going to have any subtraction of exponents. There's no other y variable in this expression. There's no numbers here, other numbers. It's just 8, okay? In these examples, I haven't shown you one where there could be a fraction here. Like, for example, if there was a 16 here, you would treat it as 8 over 16 as though it were a fraction. I'm going to show you another 5 later on. When I move on to the next topic, I'll do a review where I show 5 more problems like this, probably a couple more advanced ones in the last 2. But let's just keep going from here. Notice I have my x's. I have a bigger exponent on top with the x, a 9, and then a negative 1 in the bottom. Well, what's 9 minus negative 1? Okay, I'm just going to write it over here just to make you understand what's going on here. When we subtract a negative number, you're actually adding it. So minus negative 1 is actually plus 1. This is going to result in 10. I have an exponent of 10 up top with my x. Again, I did 9 minus negative 1. Now, it stayed up top because the 9 is the bigger number. 9 is bigger than negative 1. All positives are bigger than all negatives. My z's, I have z to the 6th and z to the 5th. 6 over 5, the z is going to stay up top in the same way the x did. And this one's a little easier. 6 minus 5 is 1. I could put a 1 here. I'll put it here for a second. And then I'm going to get rid of it because z to the first power is just z. Thanks for watching. If you have any questions about the expressions I simplified or the processes involved, comment below.